It's thermostat project update time. Been some time, I think, since this last appeared. It has evolved more than I could have ever imagined in the last 5 or 6 months. So I thought I'd run down a few things that evolved on it, and some of the things, well, a lot of the things that basically bring it, although it may not look like it right now, because it's still in between being fully into an enclosure and just being a proof of concept. It pretty much has feature parity with any smart thermostat that's out there. And you'll hopefully kind of see what I'm talking about as I go through the various features that it has, with feature parity of the current crop of smart thermostats that are out there that you might see in any big box store, online, or wherever. Let's go through some of the things that it's got. Obviously, it's no longer in pieces, and it's kind of contained in an enclosure, at least the front of an enclosure. There was a full enclosure that it was in, and so I have a great appreciation for mechanical engineers and system integrators, because I got an enclosure. This thing was just an off-the-shelf enclosure with a nice clear plastic front, and everything volumetrically would fit into it. But the problem is I didn't account for any of my the tons of wiring that is in this right now. And yes, I could have made the wiring shorter. Well, I didn't. So everything fit into the enclosure, but then it just wouldn't. It was just squished in there. And so getting the temperature sensor, which is in this lower right corner, into a position where it was not being affected by the Raspberry Pi, its heating, and then also the relays too. These guys here, I mean, when they're active, they're about 1/2 watt per channel. I think the last time we were looking at this, I had the Adafruit OLED bonnet. I think that's what it was called. And it's very nice, but the buttons didn't have any hardware debouncing on them, which I found a little bit interesting. I think perhaps because the PCB traces were so short and everything is so compact, and there's not much to it, and to keep costs down, they just didn't put any low value capacitance across the switches to facilitate decent hardware debouncing. So I did encounter weird glitchy stuff with the events that were strange. I didn't want to do software debouncing. I don't know, it's more of a personal preference, because it's easy to just solder capacitors in parallel with the switches. And so that's what I ended up doing. And so I made this button board. The OLED display had 7 buttons on it, and I didn't need 7 buttons. The color coding of things was kind of helpful, and again, it was something that I wasn't interested in, like developing a whole mechanical design and anything like that, because there's just, right now there's no money for that. So this is what I did. I did with one of the similar kind of perf board PCBs, laid it out by hand, which wasn't terribly complicated. Oh, the heat just kicked on. And so laid it out and then wired it up so that I had the 4 buttons. And that's pretty much it. The LED board stayed, although that would likely, in its next iteration, go to RGB LED instead of this individual LED configuration. The Raspberry Pi is sitting behind here. It's behind the LED board. And then the new display. So I went from a black and white, that monochrome 128 by 64 OLED display, which was driven by the SSD 1361, I think it is, but I might be wrong. I'll correct myself down at the bottom if I am. And went to this one, which is a 128 by 128 color OLED, which is powered by the SSD 1351. And so yeah, so that afforded a beautiful canvas for being able to make a bunch of different, just being able to play around. Honestly, I was just wanting to play around with a color display, and I ended up using the Luna is this mattress company, Luma framework, specifically Luma OLED, which supports a variety of different SSD-based controllers. And it's working quite well. So it's basically, what is this thing? How is it configured now? And it's what might be called in industry a dual zone 3-stage heat system. I'm not going to get into detail on how that's actually implemented, other than the fact that it uses the HVAC system, which you can see the HVAC wires that are running up the wall that way to the thermostat that's above it. And also it is interfaced to 2 separate electric heaters that I've modified to run under control by the main Raspberry Pi here. And since it's dual zone, it is also using one remote sensor and is located in an area of the house that experiences way more temperature fluctuation because of the way that they laid out the HVAC. It's kind of they put too many vents in one room, and so it warms up way faster or cools way faster, depending on the season, than the rest of the place. So that's where I chose to locate it. You can choose how you want them to be configured. So dual zone 3-stage heat, and I'm using 2 DeLonghi Slim-X 1500 watt 5000 BTU heaters. And so yeah, that works really well because it allows for nice, precise control of the heating, and it's very balanced. It's like you might expect in anybody who has a house that has dual zone heating or multi-stage heating, because that's not new. You can get a multi-stage furnace that runs on a low and high burner profile to heat the home. So I think interesting thing perhaps to dive into is the OLED display. And so if I were to wake this up, so it's just in standby mode right now, and it is in this mode to give an indication that it's operating and kind of have a cute little clock that I lifted from one of the Luma examples and modified it in a way that worked better for burn-in protections. But it is a clock and it functions, and it's nice to kind of have it. But it is operating at its very limited lowest brightness or contrast in programmatic terms. And if I press the mode button, you'll see, oh, it glitched there a little bit. Well, the first thing that we come to is the set point. So you can come in here and set what set points you'd like, and then come over here. There's I call it eco level right now, but it's just like how much money do you want to save sort of thing. But there's basically 3 levels: off, and then kind of a balanced level, and then maximize. So I myself right now, just because I'm playing around with it, it's kind of balanced mode. And then there's the configurations for the various modes. This has an auto mode where it detects a variety of environmental variables and then determines whether or not it should go into heating mode or cooling mode or dehumidification mode or nothing. And you can also turn it off, turn it to heat mode, turn it to cool mode. So this is not dissimilar from what you might see other high-end thermostats, and it's on here now, which is quite exciting. And so that is the mode function. And then what you can see now, the yellow is the instantaneous measured energy cost, which is 2.1 cents per kilowatt hour. And then at the bottom, there's the outdoor temperature, which is presently 43.8 degrees and with 69% relative humidity. But then there's a bunch of stuff for air quality and what the set point is, what mode it's in, and then the software and hardware version. And then the first screen, which this green button doesn't start with. The green button actually starts with changing the set point. The blue button brings you to this screen right away, which is kind of like your main functional screen, which is what is the current average cost for electricity, the intelligent average, what is the indoor comfort index, and then what is the indoor temperature and humidity. Before we get to Python, I'll talk about burn-in protection. If you're using one of these color OLED displays, if it's going to be on all the time and not sleeping, that you employ some sort of burn-in protection, because these modules are susceptible to burn-in. I kind of transferred everything from the monochrome display to the color display, and then kind of had to massage some stuff with the various color modes, and then I left it, and it was just sitting on this that's not it. It was sitting at this first screen all the time, 24 hours a day, as long as it was running. And yeah, it burnt in pretty nicely. And so I kind of found out about a month later, and so I was trying all these ways to exercise the pixels, so to speak, to try to get it back to something that wasn't showing these nasty lines. And so I did. I followed a couple things that were online about having moving images and things like that. And this is actually interfaced over SPI, and it's at 1 megahertz. I think I have it configured to right now. So it's not really fast. It can do a few frames per second, maybe 5 to 8 frames per second, at least the way that it's programmatically configured right now, but it's not smooth. And it doesn't really need to be. It just needs to be a constantly moving image as quickly as you can possibly do it. So I let it run for about 24 to 48 hours, and I could see it kind of fading off with this constantly just changing this image, especially with bright colors to kind of push and then relax those pixels. And so then I implemented this. I had the clock at its dimmest level, and then that clock's moving around all the time. The next thing was Python updates. So this might be a whole separate video I might do, I don't know. Especially with the Python 2.7 reaching end of life in the coming weeks. And so this upgraded from Python 2.7.16 all the way up to 3.7. And actually it's ready for 3.8, but I'm just, all the libraries that I use are all 3.7, and they don't really say that they support 3.8. So the 6 or so libraries I'm using are all, I'm on 3.7 dot, I don't know what it is, 4, 5, I don't know. Whatever the current 3.7 build is as of November, that's what I used. And I also used the 2 to 3 tool, which was, I didn't think I would want to use it. I thought I wanted to go back and like use PyCharm and set the interpreter to 3.7 or 3.8 and then see all the things that I was going to complain about. And then I was like, code's all sitting in Bitbucket. The goodness of revision control kind of helped out because I could just try this tool out. Okay, so the next thing is the simple web UI. So I'll put what it looks like up here on the screen. It mirrors all the functionality now that's on the local user interface, which is sweet, which took some time, and is a little bit of it's a challenge. I have a newfound respect for user interface designers, especially those that are like balancing between what occurs on a local interface that you're working with and a remote interface, and keeping those things synced together. It can be remote controlled through a routed, you have to have VPN into it, but that's an update on the thermostat project. More updates coming in 2020. For now, I will see you in the next one. Take care.